No, I think we are all set now to start. Hi. This is Kasturi. Hi. May I know who are all there now online? So if you can give a short introduction about yourselves, that would be awesome. May I know who are all there now online? So if you can give a short introduction about yourselves, that would be awesome.
Sahil, turn off your microphone, please.
Who are all there now online? So if you can give a short introduction about yourselves, that would be awesome.
Sahil, turn off your microphone, please.
Who are all there now online? So if you can.
I'm turned off.
Sahil, turn off your microphone, please.
I'm turned off.
Okay.
Test.
Hi. Do you hear me?
Yeah, I can hear you.
Yeah, but I don't know if they can hear me. So who's this? Whom am I seeing?
I'm Rajesh Arasada. I can hear you.
Yeah, I can hear you.
Rajesh. They can hear me. So who's this? Whom am I seeing?
I'm Rajesh Arasada.
Oh, probably I should mute my Rajesh. I should mute my. Who's this? I should probably mute my speaker.
I'm Rajesh.
No.
I should mute my. Oh, I should mute my. Who's this? I should probably mute my speaker. Yeah.
Sahil, please mute all other microphones now, because we listen us. That's the problem.
Hello. Hi. Hi. Do you all hear me?
Yeah, they all hear you.
They can?
Yeah.
How do you? I don't see anybody.
Yeah, I can hear you.
Okay. Who's this?
This is Anand. Hi.
Hi, Anand. I think it's you, and I'm just trying to see who are all there. No, it's Anand, and then who's this? This is Rajesh. This is Rajesh.
No.
Where is Rajesh? Hi, Rajesh. Hi. Hello, Rajesh.
He's muted, I think.
Oh, sorry, I can hear you. Yeah.
Oh, you can hear me, right? Okay, great. And who's the other person? Who's this?
He's Raj. I guess he doesn't have a mic or something like that. So I guess we can continue now.
Oh, he doesn't have a mic. Okay, but he will be just able to see what's happening.
Yeah. And it's for all the participants. If there is any doubt, we have a Hangout chat box. So
Okay.
To drop your text over there.
All right.
You can chat on the websites.
All right. And we have Chao here. There is another participant, Chao. So how many of you are so you had a good session on bioinformatics yesterday? You're all comfortable with the data sets? Hello?
Yes.
Okay. And you can do a PCA and everything?
Yes.
Okay. So how many of you have worked with R?
I did.
I didn't.
Rajesh did not, and Anand has worked with R already?
Yeah, I know a bit of R. Yeah.
Okay. And you all have RStudio installed in your computers? No? Yes?
Yes. Yeah, I have RStudio.
Okay. And do you also know about R Markdown?
Yes.
Okay. But anyway, so let's get started with basic R Markdown. Okay. I hope you're all able to see my screen here.
Yes.
Yes. Okay. So basically, go ahead and start a new R Markdown file. The way you do it is go to File and open a new file, and then you go to R Markdown. Click on R Markdown, and you can make a title, any title that you want. I'm marking it as test, and then I'm creating a new Markdown file called test. Okay, so one of the big or important thing that you may have to consider in mind before you do any bioinformatics analysis is to produce a reproducible code. Okay, reproducibility is a big issue now. So many stuffs, so many research are happening without we are not able to reproduce some of the results, and the main problem is that there are so many analysis being done at several places and using several methods, and the huge amount of data. So it comes at all there is a problem at every levels, and so a consistent level of maintaining the code and the documentation around the code is absolutely important. Okay, and that is why there has been set up, if you think about Python, or you have the Jupyter notebooks, or if you have the R, you have this R Markdown, and these are applications that are built around the central application, both R as well as Python, in order to actually have a consistent documentation wound around your code. So whenever I am starting a new analysis, bioinformatics analysis, I now make a new R Markdown file. So the challenge would be that you can do ad hoc. You will do ad hoc analysis, and you will get back to your code maybe in 2 months' time, and then find yourself you will not be able to understand what you did at all. So that's going to be a big challenge, and that is why it's best to have your code and at one place, and also the documentation around it. So if you can create one, let's say for analysis, an R Markdown file, you would be able to go back to your analysis even after a year or 2 years. Doesn't matter. You would be able to understand everything, and then you would be able to proceed the analysis just like how you did like 2 years back. And another important aspect of having an R Markdown is that it is transferable, right? So you can just pass down the document to anybody. It's not just you. Anybody who's going to follow up your analysis or who interested in your analysis are going to read through your code very easily. Okay, so that's one of the biggest trends. So just instead of writing a script and having a documentation around a script somewhere else, you can all organize in one big setup in R Markdown. Okay.
Oh, sorry.
Yes.
Where we can find this file?
Oh, okay. So this file is automatically generated. So go to File. You have an RStudio, right?
This is brand new.
Yes. This is in brand new.
Oh, okay.
So if you just go to File and then create a R Markdown file, it's going to open this file up. So if you open it up, there are a few things in there, which is title, author, date, output, etc., etc. And these are actually the YAML format. So these are going to be printed just like how it is being, what it's being supplied. So you can change the author, you can change the date and the output, right? There are several options for an output. It could be an HTML output, or it could be a PDF document, or it could be a Word document. And Markdown provides several options for generating the documents. Okay, so those are the first few here, and there are several options that are available. Let's not go into them. There is a big, set of things that you could do with you could do Pandoc, and you can create so many other things. If you want a different table, if you want to customize your margin in here, PDF documents, you can specify a whole lot of things using that. But let's not go into all those things. Today, we are going to go over some basic stuffs for you to get set it up and then go from there. Okay. And also, so when you come, it will automatically generate some of these things. So any R code that you write, right, is embedded in the first quotes. Like if you have these quotes, right? So whatever R code that you set up or you write can be written down under this with these three quotes symbol. It's not a quote. It's a single. What's called? It's the first character under your escape key, right? So you can start something like R. So this just means that it understands that it's going to be R code, and whatever that you write, it's going to be interpreted as R, right? And what you can do is that you can run these things. That's the beauty of it, that you can immediately run, and then it's going to give you the result just like that, right? Whatever that you're going to do in the console in R, you can do it in R Markdown. All you need to go is go and run the chunks. These are called code chunks. Okay, so you can have bunch of code chunks. By the way, if you're having any question, please feel free to stop me anytime. Okay. All right. Hello.
Yeah, sure. Yeah.
Because I mean, it just looks weird because it's like, you know, it just feels like I'm just talking without. At least in the classroom when I teach, I have students who at least nod or sleep. Here I'm not able to see anybody, right? I mean, I'm just saying. All right. So all the things that you can do is you can put these things in the Markdown, and these two headers, right? Generally, these quotes, double quote, is for the header and the size of the header. So you can have like a size 3, and you can have up to 5 sizes for these headers. Okay, and you can write whatever section that you want. You can write it with the header symbol. So these are the header symbols, and we can write everything, whatever that we want to fill it in. You can fill it in here, right? And you can include plots too, and that's usually done within the R code. When you have R, this is an example of a pressure, and there are so many options. We will look into the options a little bit later. But what one can do is that as soon as you finish writing this Markdown, there is something called knit. Do you all see that knit here? Just click on that knit. Okay, so it's going to come up. It's going to ask for a place where it's going to knit this document. So I can just say that it's going to be in the same place as this, and then I'm going to give this a test, give it some name, and then I'm going to knit it. So once I knit this document, it's going to produce a report for me in HTML. Okay, and that exactly has whatever that's being done right there, right? It has the name, the title, the author, the date, and the code chunks. Okay, and it's also going to include the plots in here, whatever plot. Okay, now once you know these basics, you can now manipulate so many things that you want to. And there is a primer for it. If you go and search R Markdown sheet, I can copy paste this for you. You can look into the options that you can give. So for instance, you can have header, list of headers, the size of the header, and what exactly does it give. So simple plain text, you can just type in a plain text, and each line with 2 spaces to start a new paragraph. And if you want to have italics, it's just one star symbol or underscore symbol. So for instance, here, if I'm going to say, like, you can also embed plots in italics, I can put like this, for instance, and then knit it, right? It's going to produce a document with that italics. You can also embed plots in italics, and you can change colors, you can change fonts. Any HTML tags that you do, you can put it in here. Also, if you are, you can put LaTeX symbols in here. So for math equations and stuff like that, you can also embed LaTeX symbols in here. So it's a very versatile programming interface and editor that you would be able to document everything within that, including code and equations and inline equations. So if you look into the spreadsheet, the cheat sheet, you'll be able to see what are all the stuff. So you can put it as an itemized things. You can put an ordered list or ordered list. Also, you can have different types of tables as well. One of the advantages is that there are so many things that you can do when creating tables. Now, for the code chunks, you can have several options inside the code chunk. For instance, you can just make, like for here, right, in our Markdown sheet, I made these 1 plus 2 to be seen, right? And that gave me 3 here. I can hide this from the output. All I need to do is that I have to say echo equals false. So here, instead R, say echo equals false. And that's going to, if I knit with that, it's going to suppress that output 1 plus 2, and it's just going to give me 3 here. And there are so many, the options that are available are here. You can make it not evaluate the entire statement. Sometime you may want to do that. And also echo, whether to display the code along with the results, or you can have a warning. Sometimes some programs give you warning, and this is going to suppress all the warnings. You can have an error message, and this can stop giving the error messages if you set it as false. And also there are also figures options, like you can set the figure width, figure length, and things like that. I did almost all of my website using our Markdown, so many things that you can do. And actually you can put it as a slideshow as well. So that hopefully gives you a basic idea on Markdown. You need to work with it to see what you like, and as an exercise you may want to create your CV on that as well. So that might be a good idea to produce an R Markdown a CV. It's a very neat interface. Any questions?
Actually, I think I missed the starting. Did you share any files or any links actually?
No, I did not.
Okay, then yeah.
I did not. I just opened an R Markdown.
Okay.
Okay, so let's go into. So once you know how to work with R Markdown, we can actually go ahead and see some of the results of visualization and exploration in RNA-seq. Okay, so basically data exploration, right? I mean, data science. If you think about data science, what is data science? What do you think about data science?
Anything that is associated with, how do what we get from the data, looking at it, analyzing it, or any manipulations or anything that we get out of data is data science, right?
Anything what you get out of data is data science. Like, what do you mean? I mean, everything is data, right? For that matter.
Right. Means in some, the process of analyzing it, visualizing it, and then getting it across the board. And all three is, the main part is analyzing and visualization, right?
So, okay, is statistics a data science?
It's data analysis.
Data analysis. Okay, so how data analysis is different from data science?
Well, no. I mean, analysis is a part of the data science. It's not different, but it's a part of it.
Okay, it's a part of it. So data science is much more than data analysis, right?
Right. Yes.
So what other things does it encompass?
Well, Manson.
Predicting from data.
Prediction
from data.
You mean like a machine learning kind of a thing?
Yeah.
Yeah, well, that's also part of analysis, right? No?
So let's put it this way, right? Means in some it's acquiring, organizing, interpreting, and then visualizing it, and then getting it across the board. Means in this. So everyone need not understand the raw data, right? So you have to put it in a way that the other people can understand it. So all this whole package is data science, essentially.
Right. Well, in a way, but let's look at what Google has to say. I mean, let's look at some of the images to see what data science some of these people say. Yeah. So one of the Venn diagrams says that it's computer science, mathematics, statistical research, data processing, and machine learning. But that is actually a nice Venn diagram. Let's see. Okay. Here. This is one of the cool diagrams that I like. Okay. So you have hacking skills, okay, which is actually a critical part of data science. And also math and statistics knowledge. If you have math and statistics knowledge in hacking, you probably get into machine learning. You should also have substantive expertise in a domain. So that's a domain of, domain is very important. So, if you have hacking skills and expertise, it's going to be a danger zone. I kind of like this definition, but there is also another definition that they say it's data science. You have computer science, math, and all, it encompasses all of it, like just like what you are saying. But the most important aspect of any of these things is that it is driven by curiosity, which is not covered in any of these things. You have to be curious enough to search the data, look into the data, and how it leads you, right? I think that's the engine that is that's propelling data science. So if you like, it is kind of bridging academia and industry nowadays, because in industry there was like no looking for exploration. It was confined to academics more than industry. But now, since we are acquiring lots of data than what we can interpret, it is kind of bridging the gap between industry and academia. So one of the key things is to basically be curious to understand what the data is telling us and to chase after some of the patterns that we see, and that is what it constitutes. So I don't want to digress here too much, but the point I was trying to convey is that one of the key things in such curiosity is about doing things again and again, right? You will be generating so many hypotheses, you will be quickly testing them, and you'll be repeating it over and over again, right? So the idea is to actually generate so many leads, and visualization is a critical for a data exploration. And there are so many visualization tools that are propped up. Are you all from biology background, or are you all from a different background as well?
I'm a biologist.
Okay, and I think Rajesh is also a biologist, no? Okay, but the thing is that visualization, I don't know if you know about Circos plots, right? There is another great tool for visualization, and there is another visualization is key for doing any data science. Okay, and what we will do is that today go over some basics of visualization, and I'm not sure if you know about ggplot. Have you heard of ggplot? So for visualization, the paradigm used to be that you can generate a bar chart, or we can generate a pie chart, or some basic line chart, line graph, and things like that. But Andy Wickham thought about it, and we saw that there are certain elements that are common across all graphics. And there are any graphics made of layers. Okay, and the layers could be there are different types of layers. One of them could be coordinates. You have any chart will have some sort of an aesthetics, and it might have points or lines which are called geoms, and it may have different types of did I cover coordinates? Yeah, and it could be some form of a there are point geoms, there are line geoms, there are different types of layer that can be embedded to make any graphics that you see. So that's the idea behind doing a visualization using a layered approach. And that is what we are going to do today, of getting familiar with the RNA-seq data that you did yesterday using this layered approach. Okay, so go ahead and install the package called Tidyverse. You all know about this package Tidyverse? Go ahead and install Tidyverse.
All of you know how to install an R package in RStudio.
Can you take us through? Yeah.
Oh, okay. Just go to console and say install.packages IDVers and then enter.
Go to console. It's loading, but you don't have it, so. Please let us know when it will be installed.
Yeah. We installed it already. Okay.
Heavy package.
Cool. Anant, have you installed it?
Yeah, I already have it actually.
Oh, sure. Okay, fine. So let's go ahead and we also need another couple of libraries called rcurl. Go ahead and install rcurl.
Okay.
Can you spell it?
rcurl.
Oh, cool. Yeah,
Are you able to see my desktop?
Yes. Now we see where you're. Okay.
We have a question. What is?
Oh, that's going to pull out the data from the web where I have put the data. So
Save voice stars.
It's install.library or just how do you get it? Install package?
it's going to compile.
No, I mean, if we start working on some
Right.
so how packages.
So basically, you will start with some code.
Can
One second, I'm answering a question here. I'll get back to you. So basically, when you start a project, you may want to. So there are most of the stuffs that you may want to program are already in the base R. For external packages, if you want to look for packages that you can actually look for R bioconductor. If you're looking in biology, bioconductor. But there's some sources. If you go to this packages, you can look for search for package, and you can download it from the R resource R base website.
Like which one I should search for?
Like so it depends on the application. Like for instance, let's say that you are trying to do develop a protocol for. It depends on specific line that you are trying to code, and if you want to do something that's already existing, you look for basically it's trying to search for Google the exact the what you really want in R, right? But usually when you come to the domain of expert, like if you're in finance, for instance, and if you're wanting to develop a package for it, there would be lots of there would be a community of developers who would have developed the package for your thing. So you just download that and then you use it. I mean, there is no rights methodology to identify, what. I mean, people might have different names for different packages that they develop, right? So, yeah. What was your question again? Sorry.
No, I got it downloaded. Yeah.
Okay.
I'm good.
Okay. So you got this R curl.
Yes, I have R curl and also the tidyverse.
Okay. So basically, what I did was yesterday you worked with these 7,000 genes, right? I have put that in this link. I have put it. I have uploaded it into Git, so you can go ahead and type in these things like the URL. I broke this URL into two pieces so that it's just two lines instead of one line, and I just made pasted. But instead, you can just have one big line of consisting of these two URLs, one link, and then I do a read.csv, and I import the data in here, the RNA-seq in here. Okay, so you can start typing it
in the console.
Yeah, you can create an R Markdown, for instance. It doesn't really take much to create an R Markdown, right? You can open an R Markdown file and you can create. But if you want to cut and paste, also actually there is. Let me try to see where this.
There's a GitHub address somewhere.
What's that?
Did you send out the GitHub address?
Yeah, let me. I have. Okay, let me do this. Okay, you can actually cut and paste from here to share that link with you here. Right. So what I'm doing here is basically importing the data. I shared the link with you, so you should be able to
In my email?
in that. Are you also on this? You're not in the Skype. Okay.
I have your page. GitHub. Is it under workshops?
Yeah, it's under workshops. Let me try to type it down. All right, so what I'm doing here is basically getting the RNA-seq data, and then I want to import the row names. I want to make a data frame to do analysis. Okay, so for me, I want to get the rows as the patients, right? There are 52 patients, and the columns as gene names, right? One of the key things that you will do when you're doing data science is that 80% of the time you would be stuck with cleaning the data. Maybe the rest of the time, like 20%, will go on doing some machine learning or predictive analytics. But most of the time, you would be manipulating how to get the data into the right format and taking out all the removing all the unwanted variables or missing data and things like that. So it's very important to get these things right. So what you do is that you go here. I want to make a data frame. First of all, I want to have a clean data to work with, and that data that I want the columns to be in the gene names and the rows to be in the patient IDs. Okay, so I can have an attribute for every patient, several attributes for every patient. So that's the required format. But when you import the data, you will see that this imported RNA-seq data is in the reverse way, right? You will have the genes as the rows and the patient IDs as the column. So the first thing is that I want to change this. So I have to get all the gene names, and that's what I'm doing here. Gene names, I'm calling it as row names of imported RNA-seq. And then I want to make a patient ID variable, okay, to make our data frame. I want the patient ID. And so I append the patient ID and the gene names and make a column names. Okay, so this is the column names that I want. The column names, it should start with the patient ID and have all the gene names in there. Okay, now I want the matrix inside it, right? And that matrix is actually the RNA-seq data that we had yesterday, but it's going to be transposed of it, right? So I just transpose the RNA-seq data here. Okay, so I look into the original data. Once you do it, you will see that the original data is about 2917 columns and 2917 rows and 52 columns. Okay, so I want the expression. I transpose this and change it into numeric, and then I want each of those patient had a group information, right? Do you recall that? Luminal, basal, normal, like.
Yes.
So I want to have the group information associated with each patient, right? So I'm importing that as well. So any questions so far? Okay. So now one of the key things that I want to do is that I see that it's all ensemble genes, and I want to have an official gene names. And if you look into this package, org.hs.eg.db, there is a package, and that helps us convert these ensemble into official gene names. Okay, so go ahead and install this library. It's going to ask if you want to install everything and compile everything. You just say no. Just install this package org.hs.eg.db. Let me know if you're done, okay? So I can proceed.
Yeah, I'm done.
Okay, so so once we can load the library, right? And then we can have an change the names of. I just want to have the ensemble names. So once you see that the official gene names can have several transcripts, so we have to have multiple mapping here, right? And once we have these multiple mappings, there will be some rows which will have no data. So I omit all the data in here. So I will make this data frame with official gene names that we will be using, so that it becomes easier for me to do the rest of the analysis. Okay, so that's what I'm doing here. I'm making the data frame here with rows 52 and columns 6680, because I'm going to have two more rows, one for the group and the other for the patient ID. And once I make this, I can make a matrix. And this matrix is what I'm going to do now, use for rest of the analysis. Okay, so the first part in any data science or data analysis application that you use is to bring what kind of a into the right format that you would be using. So once we do that, we can create the ggplot, right? So once we do that, we have a tidyverse, and we load the library tidyverse and create this plot, ggplot, right? Data equal to, just do it right now, but I'm going to tell you what this all means, okay? And you should be able to see for these two genes that you discussed yesterday, DCN and EPCAM, the expression values in here. Anyone struck? Okay. Yeah. So warning. Oh, Rajesh, he has a problem in installing this package. It's not available. All right. So to install that package, right? There is another way to do that. What you do is, go to Bioconductor, and this should help you install it. Say source. Say source, and then say cBiolite.
Yeah. It looks like it's an R file.
What's that?
It looks like an R code file.
Which one? Oh, yeah.
Sorry, what should I do with this file?
Which file?
The one that you sent me, the link here, the Biosilite.
Oh, that's going to download that. If you have already downloaded the hs.eg.db, forget it.
Oh, no, I didn't. I couldn't.
You couldn't. So you have to use the source.bioconductor.
In the console?
Yes.
Okay. It's not available still.
Why? What does it say?
It says, sorry. I'm sorry. I think I did a mistake. Sorry. So what should I type inside the install packages from source all the way to DB?
Yeah. So Biosilite org dot, when you type in, it's going to ask for whether it should install all of them, right? I usually give yes, but it's going to take some time to install.
Sorry. Under install packages, what should go into the parenthesis from source?
Source HTTPS Bioconductor, right? I mean,
Yeah, till R, till dot R.
Yes, till dot R, yeah, and then the parenthesis, yeah. So this one that I'm highlighting here.
Yeah, thanks. Now it still says it's not available for the packets. Can I type?
It's not available. What exactly does?
That's the error I get. So, sorry.
Even if you type in source.
Yeah, you can see I just sent an.
I think the more easier way initially is to just type it, cut, copy, paste it in
console, right?
Yeah, directly console and hit run.
Yeah,
that should.
That's what it did. Okay.
Don't type install package. Just
yeah. Don't go to install packages. Yeah.
Okay.
Or just go to console and just type and paste, cut and paste. Yeah. Don't. I mean, forget the install package in there. Yeah.
Okay. It's now it went through. Thank you.
Yeah. You got it?
Yeah.
What is you got?
It was not available on mine too.
Oh, okay.
Yeah, I think most of the non-R users don't know that you can install the packages from multiple sources, right? For most of the biology-related ones, it's the first line, the source bioconductor is the place from where you install most of the packages.
Right.
CRAN is for all the other packages. So I think this is where the confusion comes.
So everybody done?
It is downloading for me, so you can continue. I think I can.
Okay. So basically, what I do is this: once I you can once you have that installed, you can load the library, and that library has lots of things. Actually, I recently read about some of these things from that library, and it has some things that where you can have lots of these. The library has multiple things, official gene names, and so many things that you can you can convert, and you can work with it. So so once you have these, right, so what I'm trying to do here is that I'm trying to change the ensemble to the gene names here, and then I'm omitting all the rows with NAs in there. Did you get that? Let me know if you're having trouble at any point that you're having trouble. Should I go ahead?
Yeah.
So, may you know where you are exactly?
I could generate this code actually.
Oh, okay. So you're able to see this plot?
Yes.
Okay. And how about Rajesh?
It's still downloading for me all the files. So yeah, I think I can copy the code and I can proceed. So
Okay,
you can go ahead. Yeah.
Okay. And who's, sorry, I didn't get, it says bit Raj. What is, who's that? Hi. Hello?
Yeah.
Oh, okay. Anyway, I just want making sure that I kind of get people. Oh, okay, sure. Oh, that's Raju. All right. So once you have this, right, you can plot this on any gene that you take. You can visualize it using this using ggplot. In general, right, ggplot, it takes this argument data. You first have to provide the data. Okay, so it's a layered approach, like I was telling. This has aesthetic mappings, coordinates. It will have geoms. So there are several layered approach to visualization. So the general idea would be that ggplot, and you have the data in here, and any geom function. It could be a point geom, or if you want to create a line, it could be a smoothing. And then the general format is aesthetics, and then you supply aesthetics, what these points should take, what exactly colors that you want, and everything could be specified into this mapping. Okay, so once you have it, I would want you to run ggplot and just data equal to df, and I want you to see what it gives. So how many rows are there in the data frame? How do you see that? How many rows are there in data frame?
A view?
You can view, yeah, but view sometimes.
Oh, head and data frame.
What you can do is actually,
Summary?
Summary gives you, yeah, in general, you can use summary, or you can use end rows, or end row of how many, the data frame you have, or end column you have. Right? So if you go to the environment, you can look into that also.
It's an error messages. Errors here. Some errors.
All right. So once the good advantage of using all these things, I can execute that, right? So here I'm executing all these things, and immediately you can see that the data being generated in here. Okay, now I'm converting it. I can run this code, and I can see at any point, right? You can just look at the data here. So for instance, if I'm going to merge data, I can run this code chunk, and it's going to immediately show me the data in here. Okay, inside this. So I will be able to see. Right now, once we do this, right, we will convert it, and we will use this thing, the data frame, and you can in fact embed the plot in here, right? Now, once you have embedded the plot, right, what we can do is that we can map a color in here, right? So the point of this aesthetics, right? Aesthetics is you can embed so many colors. So we had the 4 colors: basal, cloud in low, luminal, and normal like, right? So what I'm trying to do is that here I'm trying to say the color the group by the group variable here. and it's going to immediately plot me the color, right? With each of these data points, will have the color associated with this because I've made the data frame like that actually, right? So that's the, yeah.
Still with the package. I did the source thing, and it says it's installing, but
that's okay. Let's forget it.
But I cannot call it. I was trying to do this here, and it says I cannot find it.
Yeah. If you're just doing what error? Error in select. Okay. I think it's tidyverse. Okay, so we have to.
So it's not the problem with this, but with tidyverse.
Yeah, so we have to probably load the tidyverse again.
Let's do. Should I do the source thing or the analytics?
Yeah. Source.
Oh, okay, I have to put that in there.
So, okay, everybody up to this point?
Yes.
Okay, so you'll be able to. Any questions so far on ggplot? Oh, I have to look at the Hangouts. 1 second. Okay. All right. So I'm going to go ahead with that. So how many rows are there in that? Okay. What are the expression values? Did you plot the expression values for IDH1? And make a scatter plot of IDH1 versus P10. Have you done it? I think we should, like, in general, this was the same yesterday too with like the camera and stuffs like that, right? It's
So
yeah, but the interface was exactly the same, right? It was in Google Hangouts.
yeah. What are you trying to do?
What does it say?
Same thing.
So so what is the source? What did it do?
And there's the field completion. And the asking of
Yeah, let's see. It's going to take some time, but it's going to.
same thing.
Yeah,
It was like this before,
yeah, that's fine.
but they didn't.
Just three.
Yeah.
Yeah. I just finished downloading the whole package. Can you just quickly run through what should I do?
Oh, okay. So you are able to. So what were you able to do the scatter plot and everything?
No, I didn't read so far. I just downloaded the package. Just got downloaded completely. So I just loaded the library. Can you just quickly? Go
Oh,
yeah, far behind. Yeah.
oh, okay. Sure. So you have which one that you were able to download
Yeah.
the package, right?
Yes. And
Now,
I loaded the library.
yes, you loaded the library, and you were able to run the code that.
Okay. So when I tried to run that one, it said, for example, the gene names. Said gene names not found. Object gene dot names not found.
Object gene dot names not found.
Yeah.
Okay.
So
what does it?
So the second line of code as ensemble names.
Oh, did you run the one that was before, like this one?
No.
Because the gene names, you have to.
I got it now. Thanks.
Oh, okay.
Yeah.
So after everything's done, if you don't hear everything, same problem.
Yeah. Oh. Do you know if you have Xcode in here? No.
Xcode.
Yeah. Yeah, I think we need to have Xcode in here. Oh my god. That's a you know what Xcode, right?
What?
Xcode.
Yeah. Perhaps try to install latest version of R and just install packages will work.
Really?
Yeah.
Because this I think depends on Xcode.
Yeah, so you can install R for free and install packages will work, I think.
I can try updating but Xcode, how do you spell it?
Yeah, Xcode.
Oh.
It's a huge.
It's a Apple's command line program. Command line you have.
You can move on. Okay.
That's why Linux is the best way
Right.
for a programmer.
I have Linux installed in.
Sorry, can you please check the error that I posted?
Oh, sure. So, okay. So just try to install tidyverse again. Install.packages tidyverse. Install its code. Tidyverse. So I think we should ask people to install Xcode already.
Yes, I did. Should I run it now?
Which one?
I installed the tidyverse again.
Okay, and try recompiling it.
Okay, thanks.
Sometimes it but that's not actually very important. You can forget that. But instead of using the official gene names, you can use the ensemble IDs. It should just work fine.
So this is just a package for renaming
Right.
ensemble IDs to gen samples.
Right.
That's not so important.
How should I change it? Instead of using this.
Okay. So you can go here, the environment, and look at this is 6917, right? Let's see. Expression. You don't have the package.
So I'm getting an error that says the ensemble could not find function select.
The select, I think it's the same even after reinstalling tidyverse.
Yeah.
Okay, but perhaps move forward.
Right. So so let's do this. Okay. What we are trying to okay. Let's say it without the. I think this will also be a good exercise to show. Okay. What I'm going to do is this. I'm going to go to files. I'm going to copy the visualize.rmd. Copy of visualize. Okay. Okay. So what I'm going to do is this. I'm going to not change the conversion. Okay. So let me take off all these conversion thing from here. So what I'm going to do is that I'm just going to use the existing ensemble IDs to do the analysis. Okay. So let's not get the ensemble IDs here, and we will just use the data frame. Okay. So what I'm trying to do here is I'm trying to take these things I want to make a data frame, and this data frame will have the imported gene names, right? It has 6917 observations, right? Imported RNA-seq data has 6917 observations and 53 variables. And the last of the 53rd variable is the ensemble IDs, right?
Yeah.
Now, I want to make the transpose of these, okay? So I'm going to make a data frame, and the data frame is 2 columns more than this. So what I need is 6919 rows, right? 19 rows. 19 columns, right? And 52 patients. Okay. So for the first column are the patient IDs. Okay. So what are the patient IDs? Let's see the first columns. You don't have the merged data. Okay, so the data frame 1 has, so let's okay. Want the merged data. So I want to get the column names. All right, that's fine. So my data frame 1 is going to have, this is the first, no.
What are you trying to do here?
I'm trying to create a data frame with the first column should have the patient names, right? The patient IDs. The second column should have the group information, and the rest of the columns of the gene name. So I'm just trying to transpose it. But if you're trying to just transpose it, right? Let's do a transpose of this whole RNA-seq and look at how this is, right?
TDF should work, right?
Yeah, but no, that's but it's not going to give you the exact so the important gene RNA-seq. Let's try to see what this looks like, this data frame. Okay, so this has group variable. Okay, now if you look into this, right? Okay, so look into this, what happened. So you have, it's fine, you have the group, right? And you have the columns as gene names, that's all fine. But if you look into the naming of it, right? This is just a patient ID, but I want the patient ID to be the first column, right? Now you can address the row names or the patient ID, but I want the patient ID as columns, right? So
Maybe before you transpose, maybe you should add it.
Yes, so that's one thing that we can do, but how do you add an index column before doing a transpose? So that is what exactly that's being done here. So I'm taking out these, right? I'm adding one of these variables, but instead you can actually do that as well. So let's say that here you can take the column names of of this is the row names of A, right? So let's check out the row names of A. Okay, you get this. Now we can add the data frame. We can make a data frame, right? So A is A patient ID. No names of A. So this should give us the row names. But at the end of the day, if you are just wanting to plot the genes, let's go ahead and do that with the ensemble ID. It's taking forever. So I'm just trying to make it into a. Oh, I think my R crashed.
You should make a data. Transposing.
What's that?
A is data frame.
Yeah. Yeah. I'm adding this variable, right? I mean, that's the.
Before.
Yeah, I'm transposing this data set. Yeah.
But you have to make a data.
Well, yeah. I mean, this will automatic. I think this will make it. Is it a matrix, large matrix here? Oh, this will automatically make R as data frame. I think it doesn't matter. I think my R crashed. I may have to restart it.
Interesting. GUI is running.
Okay, I have to use the hard method here. I'll use the utilities. I used to have this. That vanished too.
So why the error message occurred? The coercing.
Oh, that coercing is one of the. it's a very important concept in R. So when you have, let's say that you have a list that you have, one of them is a list is a linked list can have several data types. It could be a character or it could be numeric and stuff like that. So when R tries to read it, it's going to coerce all into one data type. Which is if you are having a character and if you are having a numeric, the numerics are going to be converted into a character. Not the other way. So there are ways in which you coerce certain strings. So coercing not just occurs only when when you have one data type to another, but there is something. If you have set of like if for instance if you have a string and if you have a like for instance if you have a double and you have a numeric, everything is going to be coerced into a numeric. So yeah, so it's a yeah, so that's the kind of, and there are precedents in which you can take, and this will be covered entirely in our course that I teach, because this is I'm just covering only the visualization aspect of things. So
how can you avoid? What's the common?
Oh, we can do an as. You can as the numeric or as vector. Yeah, right. So let's go ahead and try to do the rest of the stuff. Let's not wait for. Okay. So instead of using the gene names here, you can use ensemble IDs. Okay. Use any two ensemble IDs, and you're going to plot. Can you do some aesthetic mapping using some ensemble IDs instead of gene names? That's here. Were you able to do it? Hi.
Yes, Rajesh, I could do it. Yeah.
Oh, okay. So you are able to.
Yeah.
What did you do? What you are able to do? Are you able to get it working?
Yes, I could plot the data frame.
Oh, okay. So you used ensemble instead of gene IDs, right?
No, I think I used the gene IDs.
Oh, okay. That's great.
Yeah.
So let's go into the aesthetics. Okay. So these are called aesthetics, and what we can do is that we can have the variable color. Instead of color, we can draw. You can have the size as an aesthetic. So these are all layers. So you have a layered approach in which you map and then you plot whatever aesthetics that you want, and that could come under the AES. Okay. So or we could color to what is known as an alpha aesthetics. Alpha is the transparency. You can set the transparency for the age group. Okay. So I added two more variables. If you load this data set, instead of if you load this data set that has I had another data set. One second. What is that? Yeah, here. If you add this data set that has other attributes such as the age group and whether the person is given a chemotherapy or not. Okay, so we can add these alpha aesthetics and see. These are all visualization techniques that you can add more aesthetics. You can add the same age group. You can add the size as well as the alpha. Also, what you can do with this, you can also make a shape attribute. So these are the things that brings out contrast in your data set. Okay. For instance, we can make everything highlight as red. Okay. So if you make a GG plot with color red, you're going to have like this. So try to run this code, okay, that I'm highlighting, and see what's wrong in here. You have to tell me why. When you what does it give you?
First, it will give you a scatter plot.
Okay.
And everything will be, all the dots will be in blue in color.
Right. Is it not blue? Is it blue or is it not blue?
It's red. It's red.
Why?
Oh, yeah, right. Okay, got it. Yeah, I think I got the issue. Yeah.
Why?
Because the color is red, but the word is blue, right?
What?
No, it's this.
Why do you get red?
Because the aesthetics, under the aesthetics, even the color blue is passed. The color blue is not out.
Right. So actually, yes, that's the critical thing, right? I mean,
yeah.
The color red, you map the points to red, but here you are passing the color blue inside the aesthetics. Okay, so that's a different thing. So it's not able to interpret that.
Yeah.
So yeah, so these are some of the things that you have to be really careful when plotting with some of these things. Now let's go to facets. Okay, another key important aspect of doing ggplot is that we can do a facets. Okay, so instead of plotting in just one, you can map it into a facet wrap, which will give you a distributed way of looking at things. So if you are having these 4 variables, like basal, cloud in low, luminal, and normal, like, you can plot it into a matrix, and that's accomplished by what is known as a facet wrap, and that's a part of layered graphics. Okay, so you can have the ggplot, you can plot the data frame, you can map it, and then you can do a facet wrap, and you will see that immediately that it gives you in this. Or you can make a facet grid. If you're having more than one categorical variable, what you can do is that you can plot a ggplot and also have an aesthetics for these 2 genes. Instead, you can have the ensemble IDs, and you can plot a facet grid. Okay, so that's going to give you kind of a 3-dimensional information. You have the expression values in here, and you have the basal, the luminal types, the 4 groups, and also the age group. So with this, we will be immediately able to see some of the information that you are not able to observe in there. For instance, if you look at the 51 to 60 age group, there is no normal like people in those age groups. Or even 51 to 30, right? 15 to 30, there is no cloud in low age group people. So these are what is known as a directed insights, right? So here what I'm doing is that I'm making a ggplot with the age group versus the chemo information. Okay, and I can immediately see that there are people who are being given chemo. I mean, there are no people in 51 to 60 age group who are being given chemo. I mean, who have any of these values in FGFR or P53, right? Or we could see that most of these, right, people have higher expression for P53, right? So these are some of what is known as a directed insights, right? These are critical directed insights that you can observe when you're visualizing stuffs, right, in facet group rather than doing a singular approach. You can embed multiple things in here. Okay. So this is very important to see, and you can, for instance, one of the exercises to derive directed insights for the variables of your choice. You can try to derive what the directed insights for any of the choice variables that you like. So that would be an exercise. I would rather go ahead and do you want me to stop and make you a little bit work on this, or do you want me to get going? What is your preference?
You can keep going, actually, I think.
Okay. Okay, so the next is the layered approach is the geometric objects, right? So you have these two plots. On one hand, you have this. On the other hand, you have this. How are they similar? They are actually the same if you look at it. It's just that here you have the smoothened version and here you have a discrete points, okay? So these are known as geoms. Geom is a geometrical object that you can plot the data. It could be a point object, it could be a line object, or it could be, for instance, a spherical object. There are so many geoms that are available. Okay, so if you want to see how many geoms are available, there is a tool to find the geoms. Actually, let me. There is a. Yeah, here. So there is over 30 geoms, which you can see it here, right? So if you type in okay, so it will give you all types of extensions, and it will give you lots of these themes that are available, and you can go into the gallery and see the type of geoms and visualization that are possible in ggplot. I mean, this is just amazing. Like, for instance, here, this GG ridges. These things can be really handy when plotting some of these things. So let's go ahead with the topic. So these are called, okay. Now, for instance, you can plot both the line geom and then the point geom in the same graphics, right? This is one of the biggest strengths for using a layered approach. What you can do is that you can embed more and more data into the same plot that you have. And that's the biggest strength that you have when using a layered approach. This is a totally different paradigm for doing graphics. Do you get that? Do you get the idea here?
Yeah.
Rather than just plotting either one type of a graphics, you can add more information or subtract information or do some kind of a visual, or you can add facets. There are 7 layers actually of using this of this ggplot. That's the grammar of graphics, and this is a seminal paper actually. If you go into this, I have the paper in here for those of you who may want to read about it. Go to my webpage, and this is the original paper in the grammar of graphics. I will share the link with you. The idea behind the layered grammar of graphics. So it's a very important paper here. So you can go ahead and read about it. It's a readable paper, and it would say that how it's different from the existing the paradigm that you had originally for plotting, and how we can have a layered approach, and all the graphics share things in common, which can be done through these kinds of layered approach. Okay. So going over this layered approach, right? As I said, we can overlay, right? Now the problem with the overlaying is that here I have had the geom smooth and geom point, okay? And now this introduces some kind of a duplication in our code. So let's say that you are plotting one more thing with these variables, right? Some other geoms that you want to do. Now it will everywhere if you want to change one variable, let's say that instead of FGFR4 you are interested in HER2 since it's a breast cancer. Let's say that you are interested in ERBB2. Now you have to change everything again and again, right? But instead of that, what we can do is that we can just map into one mapping variable, and then you can just add these geoms. So it will reduce the kind of repetition that you will have in your code. Okay, so it's a very important thing to actually just have it, put it everything in one place, and then you can have a smooth or point or any other geoms that are available. So you don't have to really code it again and again, and it's going to produce the same kind of plot. Okay, now there is also another thing that we can use. We can have different aesthetics. Instead of having it in different colors, you can make all the things as black, right? So these are the things that you can play around with, different layers. So this idea of plotting different data to different layers, right? I mean, this is a very powerful thing that can bring out the contrast and that can bring out so many hidden information in your data. Okay, so as a homework, one can try this. What does a group argument in aesthetics in line geom do? What does that group argument do? Right, you have to try it in an example. So in my class, right, I will assign this and people have to do it, and then they have to submit the report in which I would be able to grade it, right? So all the things. So I would suggest you to do all these things. It's all available. Let me share this my website with you so you can try doing these exercises in here. Oh, sure. How do I send it to you? What is your email ID?
Gmail? Or the one that I used to.
Or I
Any email
can.
is fine.
What's it?
Any email is fine.
Oh, you already have a Gmail, right? Okay, so let me. What's your email ID?
JQHUANG.
7.
Yeah.
All right. So let's go into the next topic that we are having here. So you're able to, or do you want to try, or let me go into the next topic?
Just in terms of time, it's 7:48 right now, so we have quite a bit of time. People.
Yeah, that's what I was thinking. So maybe you may want to try with one of some of these things that we talked about. You want to try some things?
Sure.
Okay. So as an exercise, why don't you take 2 genes, which is our genes that we are interested in, right? The first set of the DCN and EPCAM, EPCAM and DCN, and why don't you plot both line geom point and geom smooth? Oh, but then you have to search for this EPCAM and DCN, right? Let me try to find out the mapping for these genes.
I can give you the ENSCs.
Ensembles, yeah, that'll be
You
great.
want
I think only Rajesh had the issue of ensemble, right? But he was able to map the genes anyway.
that? So it's the one that has 11465 at the end.
Oh,
Some zeros.
Yeah, a lot of zeros. So here I can put it in the chat.
you're able to meet, see if David.
I'm just thinking if that's the right one. So it's
Output post-processing.
post-processing. Yeah, so DCN, right? This is DCN. Do you see that? Do you see that?
Oh, let me see. No, what's that? Did you type it in here?
I'm trying to let me put it on Skype.
I can find that
Yes.
out.
Let's check your Skype.
Oh, Skype. Oh, okay. Wow.
And the other one is this one. That's the second one.
Okay, I'm.
This is it. Okay.
1998. Yep, can. Okay. ENSG. You're able to map it, right?
quick question.
Yes.
So apart from this, what else will we be covering today?
We will be seeing the transformation, data transformation, and exploratory data analysis if time permits. And there is also data wrangling topics are there. So let's see if we can finish data transformation at least.
Oh, so we won't be. I mean, so in yesterday's class when we were talking about the LDA and stuff, he was saying that you will be covering some part of it. You won't be doing any of that today, right?
No.
Well, so what we told them is that we will have the R code in all of those modules.
Okay.
And so, to answer your question is you already have the R code. The purpose of this workshop today was to show you also how to load the tables, how to see what's in the tables, and the data wrangling part will be about filtering and making sure that the tables are ready for the type of stuff that we did yesterday. So if you know what we're doing today, you can then easily take the code that you downloaded yesterday and run it on the tables that you have.
Okay, sure. Okay.
So you have a folder R code in yesterday's archive, and you can just access it and run it. No problem.
Right. Okay, sure.
So this is like a more data science thingy. Machine learning is a part of data science, but this is a next step for a biologist to get really hands-on doing some data analysis.
Okay.
What's it?
So we're doing the practice now?
Yeah. So where are we now? But were you able to generate the graphs for?
So what you can do is you can ask them to share their screen if they want to and show.
Yeah. You want to share the screen and show me if you're having any errors or something? So this person, I think Rajesh does not have a mic.
Okay.
Anant has.
I have a mic.
You have a mic, I know. Can you share your desktop to see if you know?
How do I do that?
Oh, so both Rajesh and Raju does not have a mic.
Were you able to complete this assignment? Or no?
Change that?
What's that?
The arrow.
The arrow?
The package.
Oh, no. It's okay. You can do with ensemble. I was telling you can do with ensemble instead of using the gene names.
Okay.
But you're doing in R Markdown, right? Okay, yeah.
I don't like R Markdown.
You don't like? Oh my God.
Yes, so, yeah. How did you make the changes?
So forget what I mean, you can just take the data frame right here, right?
So forget about this, right?
Right. Okay. So let's take the gene names in here.
Gene name is a group.
Yeah.
Or you mean the first column after you transpose?
Right. So let's.
So that's
You
like
transported.
here.
So what does this give you?
Transpose.
Yeah, I know. But, let's look at this one.
Oh, you don't need that.
Yeah.
Oh, that's you just use it to see.
Yeah, yeah. So it's just transposing this variable A.
That's it's kind of slow.
Yeah.
Because there is so much. I should just use a head just to show.
Right. Yeah.
So A is the transposed.
Right. 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 Okay. So you have the group information, and you have.
Those are the gene name.
So these are the patient names. These are the gene names. But I was telling you can still take any of these as from your data frame and do a plotting, the visualization.
After you create a data frame.
Well, no, it's still in a data frame, right? I mean, you can just take these transposed of these variable. Oops.
You mean just transpose?
Yes, right. Yeah, this is a data frame, but we really don't. We just need the 2 columns to plot, right?
And then what you do?
Oh,
you have to transpose the name.
You don't have to. So, for instance, these 2 ensemble IDs, right? So, forget all these things. Forget everything from here. Okay, so let's say we really don't have one. Right, you really don't want all these. You just need a transposed.
Don't delete it. Just
tell
me, yeah.
So you can take any of these. So you can take the transpose of these. Let's say.
But you just did it.
Yeah. So this is our data frame now, right?
Mm-hmm.
Transpose of total.
Just did it. You say you don't do that.
Yeah.
Right? A is a transpose data
frame. Right. I could have just used that, but that's okay.
But do we need that?
You don't need that. You can use DF, that's fine.
Oh yeah, I mean, do we need to transpose it?
Yeah, because you just want to take the columns, right? I mean, just do ensemble things, right? You can work with this if that's okay.
I think this is a whole data, not just the column.
Yeah, that's a whole data frame. But you can take this is a transposed, right?
Yeah. Oh, and then you
take
index
right. You can just take the 2 gene names. Right. You can just take the gene names and then you can plot it.
Use then what should I change here? So instead of data,
you can keep everything the same.
Just change the DF part.
Just change the DCN. Even DF could be the same because we are transposing it. You can use the ensemble.
What's DCN?
DCN is a gene name. Instead of the DCN, you can use the ensemble ID. Instead of these 2 as official gene name, you can use the ID that he was
ENSG name.
ENSG name. So if you open this data set, the original data set. I think it's crashed, so you may have to reload it. Yeah, I think it's crashed. You may have to reload it.
So let's see what else is happening online now.
Oh wow! Okay. So
this
is between DCN and EPCAM. Oh wow! Okay. So yeah, nice.
I just changed the gene names on the code above. So
Yeah, but you see, although it is like trying to give you an idea of the expression values. I mean, these kinds of interpolation, right? You see here, these are actually, it's a true far-fetched interpolation. If you have lots of points, then we may be able to say this interpolation is okay. But in general, this gives an idea that the expression values of what's at the luminal or probably well, it is similar to the basal, right? I wouldn't really call it as higher just because the smoothing gives you a kind of a difference. Sometimes it could be misleading, but all you can say is that the basal is really the normal, like
Yeah.
falls in between, cloud in low and these two groups, right?
Yeah.
Okay, that's neat. That's neat. What do we have with the with Raju and Rajesh? Can they share their desktop?
I just shared with. I'm Rajesh. I just shared the screen.
Oh, this is Rajesh.
Yes,
Okay.
yes.
Sorry, I thought it was Anand. Okay. Okay. Oh, nice. Okay. Okay.
What about Sahil? Sahil, what do you have?
Sorry?
What do you have? Do you want to share your screen?
No, I don't have anything to show as of moment because it's me and Malik who's doing it. So I mean, it's hard for him to follow down the thing. So I'm explaining him bit by bit.
Yep.
Okay.
Okay, well, I guess we can then move on. Right?
Okay. So okay, so we'll be moving on to the next topic. Okay, so this topic is actually more data intensive. So in general, right, I hope you got an idea of how ggplot can be used. You can add more layers, more geoms, more facets, and facets could be really useful, right? I mean, if you have other information, whatever extra information, you can plot it in there, and then you can look into it. And also, if you see that I have transformed into log scale. So sometimes transforming things, data in a different scale might give you unexpected different results that you might not know. Like for instance, I can show you an example here. Okay, this is one of the diabetes data sets. Let me see here. And I was plotting, two variables. One is the blood glucose level, hemoglobin level called A1C, and this is the urine albumin creatine ratio. Okay, so this is the raw data, which was like this. When you plot these two variables, but when you just take the log transformation, right? I'm just plotting the log, and you see that there are two clusters. So, I mean, this is just a simple logarithm can give you some insights that you will not be able to probably see if you don't, if you don't take such transformations. So it's very important to, see how your data behaves. Like I was telling you in the first place, right? I mean, it's about curiosity, and data science is mostly driven by curiosity, and the next comes the rest of the stuff. That's a main engine. And you have to play with your data set, become familiarized with be friends with your data set and see what it is trying to say in the first place. I mean, 80% of data science is actually data cleaning and doing all these things. The rest of the 20% is probably machine learning and doing some of the inference and stuff like that. So I would suggest you to play with the data. Okay, now playing with the data, right? I mean, that comes to an extremely important topic, which is transformation and exploration. Right, so this is not our data set. I didn't have we should probably it's not an RNA-seq data set. It's a diabetes data set, but the rest of the principle remains the same. Instead of this data set, you can just plug in our data set, which is there in that website, and it should all work the same. Okay, so we will first import the curated Haynes data set. It's just going to be the same idea here. what we are trying to do is that you are taking the data is online. I put it there as a CSV file, and this RCURL is going to import this data set. And I'm reading in the gender, the age group, and there are a couple of other variables in here. And I'm just going to see how the data set looks like. Okay, so str, this variable, right? Str, that shows how the structure of this data set is. So we have a regular data frame in here. You have the key, which is the patient ID, the gender of the patient, the age group the patient belongs to, and how health condition, is it excellent, very good, etc., etc. Some of these variables like urine variables, creatinine, albumin, these are all urine variables, and there are some blood variables in here, hemoglobin, cadmium. There are some glucose variables, etc., etc. So that's the general idea of the data set. Okay, so there is instead of in general the data set that you receive, right, it could be really huge. So to compress it, there is something called as tibble. Okay, so the tibbles are just nothing but data frames, but they are, I mean, that they do extremely limited amount of things that data frames can do, but they are good for viewing and doing some ad hoc stuffs. So instead of dealing with the entire data frame, tibbles can be much cleaner and they're more expressive code. Okay, so tibbles you can convert. Usually in R, anything that you can convert can be done as dot. Like for instance, if you want to convert a list into vector, you can say as dot vector, or if you want to convert into logical, you can say as dot logical. So similarly, tibbles can be converted into as dot tibble, and Haynes data set can be converted into tibble. Okay, so we'll just make it into a tibble and then just looking into it as a table, right? Instead of looking at it as a structure, this is going to just give me how the tibble looks like. So there are, when we do the transformation, there are 6 types of transformations. Okay, so these are extremely important types of transformation. You can operate on rows, or you can operate on columns, or you can create new variables. And the most important of all the transformation is a group by. We will talk about it in detail. Okay, so this is a very important transformation, and these are the 6 transformations that are extremely important and will be useful anytime that you work with the data. So the filter function, right? The filter function will allow you to pick a subset of information. So when you have a data frame, let's say that in your RNA-seq data, we just want to find all people whose age group lies between 41 and 50, and whose DC and gene is 5. You can just filter. In this data set, what I'm trying to do is I'm taking the entire data set. I want the age to be 45 and the HDL, the high cholesterol, the good cholesterol, right? Not the high, the good cholesterol, I want it to be 50. So it's going to give me those values in here. Okay. Actually, I tried to do this with our own data set. In fact, I started working with our data set. Let me show you the transformation, transform.rmd. So I'm importing the data set here for RNA-seq. Right, and the same, I'm making it an official gene name. And this is, so one of the biggest problem in using tibble is that the column name should be different. Okay, it should be unique gene names. If you're having the same names, it's going to complain. And so we have to do some kind of we have to only extract the unique gene names. And that's what I'm doing here. I'm trying to take and I'm removing the duplicated gene names and only using the unique gene names in here. Okay. Now the tibble doesn't give any errors and it's good. Oh, well, I have to import that tidyverse. Okay. Okay. So now it's not going to give me any errors, and it's going to give me the table. Okay. Uh, and we also add the age group and chemo information, just like that. Okay. So, okay, filter, right? So I'm just selecting for the group as luminal and the FGFR4 gene values less than 5, right? It's a simple function. So this is going to give me all the values for all the patients whose group is luminal, and it's going to give you the FGFR4 value less than 5. Okay, and similarly, you can look for age group. So the filter function actually filters the rows. Okay, and all of these are called deep layer. Okay, deep as in deep layer, DPLYR functions. Okay, they are going to create a new data frame. Okay, so it's important that we assign this to a new variable and then use it. Usually, that's that. And also we can use comparison logical operators. So, for instance, here I'm using this ATM gene, and I want the groups between 31 and 40, and and the ATM value. So you can use logical operators inside the filter function. Similarly, you can, this is just for a chemo, the same example where the chemo function is 5, right? So one of the key things to note is that the filter only includes rows where the condition is true, and it also excludes both false and NA values. Okay. So as an example, find this. Find all patients who are not given chemotherapy and have P53 levels greater than 5. So can you do this exercise? These should not take too long.
Can you repeat the conditions?
Oh, what's that? Sorry.
What are the
Questions?
Yeah.
Oh, sorry. 1 second. You able to do it? Oh, so, okay. So you. Oh, okay. If you use this, you don't really need any of the gene names. If you can just cut and paste it, it should work fine.
Oh yeah, I know that. I have no.
What's the data frame here?
No, this doesn't have to do anything with genes. Oh, the data set that I have?
This one?
Yes.
What's this?
That's a diabetes data set. What's that? Sorry?
What's the data frame? Because we don't have the data frame, right?
Did I not share? Okay. The data frame is just the same data frame that we had last time in that visualization.
Okay.
So I thought this is Rajesh, right?
Yes.
And you got the official gene names. The data frame is just the same data frame.
Okay.
He's sharing his screen? Or?
Yeah, he's following these questions.
Wait, can you see the screen? Or is it...
Can I see your screen, Rajesh? If you don't mind.
Yeah.
Sorry. Actually, I can cut and paste it in. Oh, the unique, right? Okay, let me give you that. Sorry. I think it's giving you the error that you don't have the unique.
How do we get the column names?
Like what column names?
What is the name of the column or the row to filter through? Like age group, that's the column name, right?
Oh, you mean the age group and all these the column names or the gene names, right?
Not the column, rows. You're filtering through rows, right? Sorry. I'm used.
Yeah, it will keep only the rows. So it will take each column, right? And it will filter those rows out which does not meet the criteria.
Yeah, I understand. But how do we know the names of them?
Of what? The rows?
For example, he said, for example, the second condition here said in the age group 41 to 50, right?
Right.
Luminal type. So for the age group, what's the column name or row name or the filter name? Is it like age group?
No. See here, right? For instance, I'm taking P53. Value should be greater than true, and ATM should be less.
So how do you know that it's P53?
Oh, that's the gene of interest. That's whatever that you are interested in, right? I mean, there are 7,000 genes, right? I mean,
okay. Can I ask you? For example, here it said the second one. It said in the age group between 41 and 50, and have a luminal type, right? So, if you go back to the for luminal type, if we say the group is equal to the luminal, then we select the rows with the luminal type, right? So I'm asking, where do you get that name group?
Oh, that is the initial data frame, right? I mean, that's why you form this data frame. So it's best to form a data frame, especially with the group information. I added this group information, right? So, so here I say that column names unique, this patient ID and group.
Yeah. So where do we find the, if for example, let's say I have a data frame, but I want to know what are all the names that are the column names in the data
you can type in call names, right? So this is COL of DF.
Thanks.
That's going to give you all the column names in here.
Okay.
Ready? So
we're on the code.
You got the code, right? Did you paste it in your
everything?
Yeah, not everything. Just take the code chunk.
That's the first part.
So let's do it right. Oh yeah, you got it. So yeah.
So we're here right now.
Right. And next one. This is right. No, you can view it as a table.
So we're here.
What's that?
Where are we?
Oh, we are in. We are in filter.
Oh.
We are able to find the place, right, David?
Yeah, it was great. Good conversation.
This office is good, right? Right.
So what are we waiting on somebody to show something, or?
Yeah, we are. Let's see whether got it. Oh, so okay. So you need to type in luminal. Yeah, that's right. Let's see.
1 equals group equal.
Oh, group equal.
Yeah, sorry.
Was
Still I get this. I still get the same error, isn't it? Am I still in the maybe? Do you hear me?
Sorry. Let me look into your code. Okay.
Sorry, yeah.
So df, just type df.
Yeah. Oh, just type df.
Yeah. Okay. So the df is already there, right? I think what it's trying to do is when you type in filter.
Yeah.
You already loaded the library, right? The tidyverse.
Yeah.
So just filter df. Comma. And what is your what data frame? Is it just that data frame, or did you have anything else in here?
I don't know, maybe. That's the DF, right? That's 52 observations and 6,682 variables.
Right.
Yeah, that's you see here. It's on the in my environment. I see that. Yeah.
Right. And 52 observations of 660. Okay, so just put TP53 greater than 5.
Okay. I think my R crashed. So.
Oh, okay.
Should I be loading everything again?
Oh, okay. That's okay.
Can I go back to history or something?
History. No, I think. Oh, you did not save the R Markdown or anything?
No.
Yeah, you should be able to find if you have it in your history. Just try looking into the history, or just cut and paste. You don't have to work with the gene data set, but you can work with the diabetes data set.
Okay.
It is there in my website. I can give you exactly the page. So that should be easy. Just cut and paste it. You should be fine. Are you getting it?
What's or in R?
What's that? Oh, the pipe symbol. Yeah, you can go into this, and
okay,
you should be seeing. Yeah, I did save, so probably you just need to. Yeah, you should be fine. Yeah.
And the data frame is Haynes?
Yes. And I have the codes in there.
Sorry.
You get it?
Which version?
Any of these questions. I just asked to. What does it mean? Here and this.
LHS.
Okay. Got the idea? You got the idea, right?
Yeah. How to do the last missing scenario just now? Or
So, object HDL not found.
CHDL, yes.
It is there. Let's see. Age group. Oh, the age group is an integer, right? So,
yeah, but the even I tried without. I know it's not a string, so I just tried integer the first filter. It didn't work. Like 20 to.
Did you try the first one? Filter SP age equal to 45 and HDL equal to 50.
Yeah, this one.
Right.
Yeah, I'm just running it. See, you get the error.
HDL not found. Why is that? Type in Haynes. Yeah. Scroll down a little bit.
This one?
Yeah.
Okay, HDL.
One equal sign.
No, he has two equal sign.
It should be one, right? It's number.
What's it? It's
number, so it should be one single equal sign instead of double. Two equal sign.
No, two equal sign is the equal to if it matches that, right?
But it's a number, right? It's not a character.
Oh, did you type in tidyverse load the library? Oh well, it's a part of that library, right? So why is that?
I used.
Did you load the tidyverse library? It's already part of. I thought I loaded the type. Oh yeah, maybe you should load the tidyverse. Say load.tidyverse library.tidyverse.
This one?
Yeah, just try that. Okay, yeah, it should work. Yeah. Yeah, now try it. Yeah.
It did filter, but okay.
Right.
Yeah.
So, yeah, I think that works.
Yeah, that works.
All right, so let's go to the next ones. Okay, so I think this is fine. I'm not going to spend too much time in here.
Can you explain number 8? Like missing value? How do you use that?
Okay, so what's number 8? How many patients are missing UACR values in the Haynes data set? You have to use NA, is dot NA.
Is not an A?
Is dot NA.
Oh,
so, yeah. All right, let's go into the next. Okay, so that's the filter function. And another important function is what is known as arrange function. Okay, just like how filter filters out the row, arrange works like similar to filter, but it changes the order. Okay, so it will not filter, but it will change the order. So for instance, if you say arrange Haynes by gender and age, order by the descending order of these eucreatinine. Okay, so that's going to order these in the value of descending order of the eucreatinine value. Okay, so it's going to take the SP age and then age group, and then it's going to by the descending order. You can also use tail and head functions. Okay, so you can use tail, and that's going to give you the bottom values, and it's also going to give you the head. Head also gives the top portions of it. Okay, so sort the Haynes to find patients with highest cholesterol. Can you do that?
Yeah. It's data frame dot arrange.
Yeah. Not data frames dot arrange. It's data frame. It's arrange. Just like filter, it's arrange. The data frame, and then the what variable that you want to arrange. It could be gender or age, or
Okay.
it could be key. It doesn't matter.
What's the question? We arrange by
but the highest cholesterol. So it's in the descending order of cholesterol, right?
Yeah.
Yeah. DAC and cholesterol. DAC.
Easy.
No. You don't have it's not equal to, but you just say DESC, descending order of cholesterol.
Total? If there's a space, it doesn't matter, right?
No. Cholesterol, no, it's the total same. It's a one word.
Well, if it's ascending, then just change it.
Yeah, arrange.
Default is ascending.
That's it. Yeah. All right. Okay, let's go to the next one. Select. Like instead of just like using filter and arrange for rows, use select for columns. Okay, so the select is going to choose the columns. So here is the code where you select only the hemoglobin and glucose, right? So you take S as select the Haynes data set and A1C and glucose. So it's as simple as that. And it's going to give you the A1C and glucose, right? I mean, it's just going to select only those columns. And there is also a helper argument which says everything. Okay, so that's going to select everything. It was going to keep A1C and glucose in the front, but the rest of it is going to keep everything other than it's going to push the rest of the stuff. So here it's going to take the A1C and glucose, and it's going to put everything else after that. Okay, so that's a very useful thing to do. And there is another important function called the mutate. The mutate, what it does is that it creates new variables from the existing variable. So you can add new columns. Let's say that you have a data set in which you have time, and you have a data set with distance. You can create a new column saying speed equal to distance by time, right? So that's something that you can make. And this is, for instance, here, right? This code makes a new variable that's a sum of the high cholesterol, the good cholesterol, and the bad cholesterol, and it's going to store in this value HL to find the ratio between the cholesterol, right? And I'm going to do so. What I'm trying to do is here, I'm only selecting a subset of the Haynes data set, in which I select the Haynes LDL estimate, cholesterol total, triglyceride, etc. And I'm trying to make a new variable H_L, and I'm adding these two variables and then forming another variable is called ratio. Okay, I mean, this is for diabetes, but in general, you can do it for gene expression if you want to form another variable that is a sum of, or you see how one gene expression is related to the other. Rajesh, you are a biologist, right, or no?
Yes, I am.
Okay, so you can do the same thing. You can form the new, estimate, which is say mutate. So that is what the mutate data is going to do. So this data gives you that the HL and the ratio here. Okay. The transmute will only keep those variables, will only retain the created variables, and it will not retain any of the prior variables. Okay, so that's called transmute. And there are lots of useful functions like lag, lead, etc. We can wrap around these things, and you can take the top function that is made out of the filter function. Actually, these are wrappers, but you can use these things like you can top underscore n. Will take the top 5 values of the ratio. Okay, so these are some important functions, especially mutate. You would be using a lot actually. Yeah. Any question? Yeah.
Is it the same thing as you use, say, data frame and then dollar sign, the new column name, and then column
right?
Plus column.
Yeah, you can. You can introduce a new column to the data frame like that as well.
But what's the benefit, advantage of using it?
Right. So the biggest benefit of using a mutate is that usually when you create the new variable, you are now working not with data frames, but you're working with a subset of data frames and tables and things like that. So if you're creating a new variable with mutate, you would typically use with additional, like for instance, calling, let's say that you have a new variable called which is probably that's made up of, you don't have to really use the columns, right? I mean, when you put it under the table format, you can just use the column information rather than the data information from there. So let's say that you want to create a new variable called speed when you're given distance and time. How do you really do that within the data frame?
Within the data frame?
Yeah.
Just divide.
Divide how? How would you divide actually?
I understand.
Like if you had a dollar, you're forming new speed.
Yeah, dollar speed.
Speed, and then
the data
what?
Divided by the data dollar time.
No, that is a list. Right? What goes under the right hand?
That's a list?
Yeah.
Why that's a list?
Try it out. How do you create dollar? So that will take.
So it's not doing the calculation one by one
No.
at the same time.
Right. So the operations, right? They are defined under mutate actually.
So as long as you are doing some calculation on the data, you have to use it.
Right. Yeah. So instead of using for loop and creating another thing, this is already built-in things that's done. Okay. This is by far the most important thing that you would use in data sciences, that the group by and summarize functions. Okay. So these are very critical functions. Let's say that you have a group of genes that fall under some pathway, and you want to see that what's the mean expression of the pathway, right? What you can do is that you can use a group by operation. Okay. So for instance, here I have Haynes by gender. I want to group by gender, male and female, and I want to take the mean cholesterol level. So what I do is this: I take group by the Haynes data set, I group by the gender, and I want to take the mean cholesterol. Okay, so this is going to give me a data set, a table with gender. For male, it's 183, and for female, it's 187. Okay, so that's the importance of group by. So if you are having a bunch of genes, and if you want to take the mean expression, or if you are working with a probe set data and you want to convert into genes, you can use this into use the group by operation. All right. I'm sorry. Okay. So the summarize also has useful functions called the count. Okay. So summarize has several functions such as the count, such as the mean, etc., etc. So for instance, here is an analysis where you take the HDL and LDL for each group and group by the number of patients with a particular age. Okay. So what I do is that by age, I group by Haynes with the age information, and I take the mean HDL, mean LDL, and I count where the group of more than 5 people, remove more than 5 people, right? So, and then I plot the data. So this is using the visualization. And then you see that you see the count of how the distribution is. This is H and this is L. That's the mean HDL and LDL. And I plot the number of people who are more than 5 HDL versus the mean HDL versus the LDL, okay, by the age group, right? By the age category, all right? So the biggest disadvantage is that often when you're doing data science using these things, you will be using the variables again and again, which can be eliminated with a pipe symbol. This is called the pipe symbol, okay? So as the analysis becomes complicated, piping will become extremely useful. So like for instance, what you can do is that you can pipe this information into this, and again you can summarize it, okay? So this is called piping. And piping is a very important, useful function that you will always use in using this, okay? Missing values is typically used by this function na.rem, so that will you can remove the missing values, and for instance here, right, you can use without removing na. There is a difference when you sometimes, usually it's best to remove data set with na, because those are the things that can really cause some problems sometimes. Or you can summarize. The mean could be different, right? I mean, if you're not using the NA or using the NA, it could matter when you consider the number of people and stuff like that. So it's very important to actually remove the NA values first. And then you can take the values. You can take the mean or aggregation, okay?
Can we fill in the values?
What's it?
Can we fill in the values by taking, say,
well, yeah, you can do that actually. That comes under the wrangle portion of it. We will cover it later. Maybe not today, but there is a whole bunch of how to deal with such things, right? I mean, there is a whole science behind doing filling the missing values. You can do an interpolation, you can take an average, and so many other things, and those are all possible.
Okay.
We can do an aggregation using group by. It's usually it also the people use with count information too. So here, Haynes, you're grouping by age and gender and summarizing it, right? And we can also plot with the count information and using what is known as a geom. We saw there are so many geoms, right? Polyfrequency of the polynomial is also a geom. So we can plot along with these geoms to see the count distribution. Okay, so that's going to give you that. So some of these things, right? We have to play with the data set to see how they give. So you can use your own data set to find all these point geoms or smoothing function. So at this point, I would actually ask you to do some basic things of apply this to the RNA-seq data set for the genes of your interest, and then give the results. I would say that I think that would be the one of the exercises that you can try it out. Maybe you can try to find this for, but you don't have to import all the stuff, right? Maybe you can try to do it for HDL, right? Do this example 1 for HDL.
what are we doing? We're grouping by.
Yes, you're grouping by.
Yeah.
The exercise is to actually grouping by the age group, and you're trying to find the mean HDL.
After missing that,
And HDL when glucose
I didn't find the exercise.
So no, I'm just giving you an exercise for this based on the example 1.
Okay.
You have to do it instead of cholesterol total, try it for HDL.
Okay. Oh, I have a question. How do you do the starting in a different one?
Oh, in R Markdown, if you just press it in R Markdown, you should get it. But if you're not using R Markdown, if
I set in console.
Oh, then
And then
yeah. Oh,
how do you do the?
No, if you just press enter, it's going to the next line. But if you want to close it, right?
No, I don't want to. Like, say if it's too long, I'm not go to the
second line. Yeah, but I think just the enter would work.
But if you enter, it will run the code. You just in console.
No, if you don't really complete it, it will not go into add a plus.
Oh, okay.
So.
Oh, I'm not in console. What about in here?
Here it will go to the next. Yeah, it will go to the next.
I have the same problem. So if I press enter, it's running the function. What do you do?
Oh, is it not running? So let me see here, right?
You see, in the example, there is indentment in front.
Right. So let's
so how
take,
do you do that?
Like, okay.
So here,
right?
Yeah.
Let's do this. Okay.
Okay, it's a shift enter.
So here, right? So if you do this, it's going to have a plus. Okay, it's going to add plus. But if you want to close it,
no, I want to make it look like this because if you like I roll, it will not look like this.
So here, right? So if you want to, right?
No, if it's like a very long.
You want to? Yeah. I think in Windows, it's I think it's shift enter.
Shift enter.
Yeah, it goes to. So you got it?
It's mean what? HDL?
Yeah. So the exercise is just to replace cholesterol with mean HDL. So you can see this. You can inside cholesterol total, you can specify the glucose variable too. Just cut and paste it, I guess. Oh, you have to specify which data frame that you are working with.
Yeah.
So, you know, yeah, but yeah, that should, well, yeah, you can do that. But actually, the best is to pipe actually from one result to the other. So typically, that's the importance of piping. Like,
Now I got the concept of piping. Okay.
yeah. So you can put the result from gains, and then you put it, and then it will direct all the data to here, and then it will print out. All right. Great. So, with this, I would suggest you to work through some of the exercises and feel free to reach out to me. See, here you have not given the results, right? I mean, you have not piped in the results. But I would suggest, to work on these things. The more you work, right, it's better. That's the key about things about data sciences or bioinformatics for that matter is, anything for that matter. The more you work, you do, you mess your hands, the better it's going to be. So I would suggest you to, work on these things quite a bit. And feel free to reach out to me anytime, okay?
Yeah, sure.
So I think we will stop here. It's already 3 hours today.
Yeah.
You guys would be exhausted. So let's try to see if we can meet sometime.
Sure.
All right.
Yeah. Thank you very much.
All right. So yeah, have a good day, and we'll meet sometime.
Yeah. Thank you.
Bye-bye.
R code is pretty much like if you want to do math, statistics, you use R code.
Yeah, but I think it's one of the best things for data science. I mean, all these tidyverse is a very good package.
Yeah, like tidyverse. I heard of tidy and DR something, DYR something. I get confused with the names. The tidyverse and tidy what's the difference? Is there a tidy?
TidyR.
Yeah.
There are some TidyR. So tidyverse is a big package that has tidyverse, ggplot, TidyR, and then dplyr. Everything is packaged, pure R, and so many other things. Yeah.